Hello everybody, this is Mrs. Pound and I am back with the last video for this chapter, Chapter 2 on Matter from BJU Chemistry 5th edition. And today our topic is going to be about the states of matter. So our objectives today are going to be to summarize the kinetic molecular theory of matter, compare the states of matter on the basis of their physical properties, and summarize change in state as energy moves into or out of a substance. So, in order to understand the different states of matter, we have to have an understanding of the kinetic molecular theory. And this theory states that all matter is made of particles in constant motion, and their motion increases with the addition of energy. It describes the movement of particles in matter. And I have a picture of Niagara Falls in the background because we can really visualize all of the states of matter in that picture. So the first state of matter I want to talk about is a solid. So solids have relatively little kinetic energy compared to attractive forces between the particles. The particles vibrate in fixed positions, and it has a fixed volume and fixed rigid shape. Now, going back to that first statement, the motion is not enough to overcome the attractive forces. The attractive forces are stronger than the motion between the particles, so that's why they are held um, in place the way they are, okay? The next state of matter is the liquid. These particles have enough kinetic energy to partially overcome the attractive forces between them. So they're no longer just vibrating, they're actually sliding over one another. So the particles can slide. They have a fixed volume and take the shape of its container, not easily compressed. So they're still really close to each other, so we cannot compress them really closer together. That's what that means. Now, gases have enough kinetic energy to completely overcome attractive forces. They are just flying all over the place. Especially now, right here after this, ideal gases. Okay, a gas is never completely ideal, but some of them get very close, and when they completely overcome these attractive forces, they are called ideal gases. So, like in parentheses, put ideal gases after this statement. They're fast-moving and widely spaced particles. And there's no definite shape. They expand to fill the container and they have ease of compressibility. That is why we can have compressed gases. Maybe you have a gas compressor at home. This is why we can inflate tires because we can compress that gas inside of a tire. Now, when a substance has thermal energy added to it, its particles either gain kinetic energy, resulting in an increased temperature, or the substance experiences a change of state. One thing to note is that when a change of state is occurring, the temperature remains the same. For the substance. So, for example, when ice is melting, as long as there is solid ice present, we know that the temperature is 0 degrees Celsius because all of the energy is going to rearranging the molecules, not into increasing the temperature. While water is boiling, it stays at 100 degrees Celsius because, again, the energy is going into changing the interactions, breaking up those interactions between the particles instead of increasing the temperature. So some phase changes, which is a physical change of state, are as follows. Now remember, when we have a phase change, it is still chemically the same substance. Okay, we're not changing the substance. You still have water, H2O, even though that one's kind of tricky because we have different names for the different types of water. You still have the same substance. So condensation, this is when something goes from a gas to a liquid. There is actually a loss of energy, okay? And an example would be dew on the grass. We have vaporization. This goes from a liquid to a gas, and this is boiling and evaporation. Boiling is when we have rapid vaporization throughout the whole substance. Evaporation is just when it's off the surface. There's also freezing when we go from a liquid to a solid. So we have a slowdown in particles there. Melting from a solid to a liquid. And just a note on this one, the reason it feels cold is because the energy is going from your hand to the ice to melt it. We also have something called sublimation, where we go directly from a solid to a gas. Some examples of this are ice cubes in your freezer. You might notice that they shrink after a while. And in the background here, dry ice goes directly from a solid to a gas. There's also deposition from a gas to a solid, and this is when we have frost forming on plants, which will be happening here soon because uh, it's fall where we are right now. So our objectives for this video were to summarize the kinetic molecular theory of matter, compare the states of matter on the basis of their physical properties, and summarize changes in state as energy moves into or out of a substance. So don't forget your 5 questions, and you can start studying for the test because you have all the information you need.